Hello everyone, today we will be presenting about direct and inverse proportion. Our group members are Quentin, Kimmy, and Kara. Here is the overview. The objective of this lesson is to understand what direct and inverse proportion is, and to use direct and inverse proportion in a real-life setting. The first thing we will be discussing about is direct proportion and its examples. Third is inverse proportion. Fourth is examples of inverse proportion, and lastly, application and reflection. What exactly is direct proportion? Direct proportion means that when one value increases, the other also increases at the same rate. And when one decreases, the other decreases too. In other words, both values change together in the same direction. For example, imagine you're converting miles to kilometers. The more miles you travel, the more kilometers it becomes. That's a direct proportion because the distance in kilometers always increases when miles increase. As you can see in the table on the left, it says that when the miles equals to 25, the kilometers equals to 40. Now, it wants us to find how many miles are in 100 kilometers, and also how many kilometers are there when there are 125 miles. So to solve this, we can use the formula for direct proportion, which is miles over kilometers equals the constant. So, using the first pair, or 25 miles equals to 40 kilometer, the constant will be 25 over 40, which simplified is 5 over 8. So that means for every 5 miles it's 8 kilometers. Now, we can use this to find the missing values. First, for example, when kilometers equals to 100, we can say that miles over 100 equals to 5 over 8. Now, we can multiply both sides by 100, which is 5 over 8 times 100. And the result will be 62.5. So, 62.5 is 100 kilometers. Second is when the miles is 125. We have to find the kilometers. What we can write is 125 over kilometers equals to 5 over 8. Now we can multiply both sides by kilometers, which will be 8 over 5 times 125 equals to 200. So 125 miles equals to 200 kilometers. That's how we solve problems using direct proportion. The graph on the slide shows a straight line passing through the origin. That's what direct proportion looks like. It means as one value goes up, the other goes up in a straight line pattern. To summarize, direct proportion means two values increase or decrease together. The graph is a straight line through the origin. And finally, you can solve missing values using the constant ratio.
So next off, we have inverse proportion. What is inverse proportion? Inverse proportion is a type of relationship where when one quantity increases, the other decreases. And they balance each other out so that their product stays the same. So we have an example in the right here. So the amount of time it takes for 5 workers to do one job is 108 hours. But when but the question is saying how much hours will it take for 9 workers to do the same job? So because this is an inverse proportion, we can use this equation. So the first number of workers times the time taken for that first amount of workers to do is equals to the second amount of workers times the amount of hours that the second worker does. So basically, it's 5 times 108 is equals to 9 times t because we don't know t yet. So basically, we solve for t. So we isolate 9 by dividing it from both sides. After that, we get 5 times 108 divided by 9. After that, 108 times 5 is equals to 540. So basically, we divide 540 divided by 9, which is 60. So we found it. T is equals to 60. So the time needed is 60 hours. So, in summary, inverse proportion means that as one value increases, the other decreases, and the product stays constant. This is a useful concept for understanding teamwork, speed, and efficiency in real life.
Now I'll be talking about application and reflection. So, looking back, it is useful to learn inverse and direct proportions because it helps us in the real world. Some examples of inverse proportions are the freshness of vegetables and time. This means the longer the time passes, the less fresh the vegetables become. When time increases, freshness decreases. For example, if you buy vegetables today and leave them for a week, they will not be as fresh anymore. And also, expenses and savings. This means the more you spend, the less you save. When expenses increase, savings decrease. For example, if you buy too many things, your money left in your savings will go down. And also, toys and free space in the room. This means the more toys you have, the less space there is left in your room. When the number of toys increases, the free spaces decreases. For example, if you keep on adding toys to your shelf, your room will get more crowded. Thank you.